These are the 7.2 video notes. We're going to continue with some inverse trig functions. We're not going to spend a ton of time on cosecant, secant, and tangent because it's kind of the same principle. We're just going to start applying that right away. And then we're going to look at some different ways that we can think about inverse trig and writing them in some different manners. All right, so we just got some straight up rules for the secant, cosecant, and cotangent. And we can see what we really need to pay attention to for our inverse functions is when we are looking at where we're applying them, we are talking about between 0 and pi for secant. We are talking about between negative pi over 2 and pi over 2 for cosecant, and between 0 and pi for cotangent. As a reminder, secant goes along with cosine, and when we think about our cosine inverse, that is between 0 and pi. Cosecant goes with sine, and our sine inverse goes from negative pi over 2 to pi over 2. And then our cotangent goes with tangent, but our tangent inverse goes from negative pi over 2 to pi over 2, where the cotangent goes from 0 to pi. And we're going to see what this means and how we have to apply it in a second. But when we're thinking about our inverses, we have we've got a different range of answers that we could have for our cotangent than from our tangent, where our cosine and secant lie together, our sine and cosecant lie together. So those are very nice because they work the way they should. Tangent and cotangent is a little bit different, even though they are paired very strongly. When we do these inverse functions, we're looking at some different quadrants. All right, we're just going to break this down. So finding what is the inverse cosecant of 2, again, I'm asking myself, what angle creates a cosecant equal to 2, or I've got cosecant of some random angle question mark, and that's equal to 2. So what is that question mark? In this case, pi over 4. If you take the cosecant of pi over 4, you get 2. And that's all you have to do is I'm asking myself, what is the angle that creates this cosecant? This is between negative pi over 2 and pi over 2. This is a quadrant 1 angle. So it is just that simple. We don't have as nice of a chart as we have with the others. You actually have to start kind of considering where this is. You have to think about what angle creates this cosecant and which one am I looking at depending on the quadrant. And we'll do the same with secant and tangent. And this is our only example because, again, we are just going through the process of saying, what is this angle? Which angle is this? We should have practiced that enough with our sine, cosine, and tangent where we understand the principle. Now we're just expanding it to our new trigonometric functions. I'll make sure to do a couple more examples in the video answer key if we're still struggling. All right, now finding the inverse via the calculator, this is a little bit more complicated. We're going to start thinking about our trig relations here. For the inverse secant, we obviously don't have an inverse secant button on our graphing calculator. The Texas Instruments Corporation decided that in order to maximize their profits, they couldn't spend any money on the plastic for the inverse secant key. So what they're going to do is we're going to find a workaround. We're going to apply some mathematical principles in order to use our calculator. What I can say is that the secant of theta is equal to 1 over the cosine of theta. And now I can say that I know that I am set that 1 over the cosine of theta is equal to 3. So then I can say that, all right, that means 1 is equal to 3 times the cosine of theta. And then the cosine of theta is equal to 1/3. So that means theta is going to be equal to the cosine inverse of 1/3. I can simply say that this is just going to end up being the reciprocal of it. That's the quicker way to get there, but this is the reason why I can do the reciprocal, is I can set up this mathematic relation of how cosine and secant are related, and I can go through the process of creating that inverse function. Once I'm here, I just go ahead and plug this into the calculator, and I do the inverse cosine of 1/3, and I find that my answer here is 1.23 radians. And that is my answer because these have the same value. I can't do the inverse secant on a TI-83, but I can do the inverse cosine, and I can use my knowledge of the relations to get there. Just like with cosecant, I can go through this whole process. I can say the cosecant of theta is equal to the 1 over the sine of theta, which means that 1 over sine of theta is equal to -4. I'm going to go ahead and jump a couple steps here. I'm going to say that the sine of theta is equal to -1/4. So therefore, theta is equal to the inverse sine of -1/4. I'm using the fact that I have this reciprocal identity for how my cosecant and sine work to utilize the buttons which TI-83 makes available to me. And it's just going to end up being the reciprocal. And at this point, I'm going to stop solving for things, and I'm just going to start using the reciprocal from this point forward to make my life a little bit easier. So I'm doing the sine inverse of this -1/4. I plug this in on my calculator, and I get -0.25 radians as my answer. For cotangent of 1/2, I'm going to start thinking about the cotangent a little bit differently. So cotangent, your y has to be between 0 and pi. And then for tangent inverse, your tangent inverse again has to be between -pi/2 and pi/2. And what I can see here with this 1/2 is that this is in fact going to be a quadrant 1 angle. And cotangent and tangent both have quadrant 1 in common. 0 to pi/2 is going to be the same as 0 to pi/2 here. So cotangent inverse and tangent inverse have quadrant 1 in common. When we do this, these are the ranges that exist for those y's. So that means when I figure this out to plug it in on my calculator, I'm just going to do the tangent inverse of 2, because 2 is the reciprocal of 1/2. And when I do the tangent inverse of 2, I end up getting 1.11 radians. And that is my answer. So because these are both quadrant 1 angles, I can just use inverse tangent, and that works really, really well for me on my cotangent. This is going to change a lot when I get over here, because now I'm looking at cotangent of -2. Cotangent's between 0 and pi. So this means that this is a quadrant 3 angle. If you type the inverse tangent of -1/2 into your calculator, you find that your answer is -26.565 degrees. Now, obviously, that is a quadrant 4 angle. It's negative, it falls in quadrant 4. Cotangent doesn't fall in quadrant 4. Cotangent falls in quadrant 3, or 2. Cotangent, negative cotangents fall in quadrant 2. So that's a quadrant 2 angle. I apologize, quadrant 2, negative cotangents fall in quadrant 2. So I start thinking about the buttons I have in my calculator. My sine inverse falls in quadrant 4 or quadrant 1. My cosine inverse falls in quadrant 1 or quadrant 2. And then we've already learned that our tangent inverse falls in quadrant 4 or quadrant 1, depending on if it's a negative or positive. Now, I say to myself, okay, this cotangent of this negative angle in quadrant 2, the only function on my calculator that will get me to a quadrant 2 angle is my inverse cosine. So what I can do is I can say, all right, I know that I've got a cotangent of some theta which is equal to -2, which means that my adjacent over my opposite is equal to -2. Which means that I can arbitrarily assign my adjacent to be -2, and I can arbitrarily assign my opposite to be 1. Now, it doesn't matter if these are the actual values or not, because they reduce to this value, and it's still going to work out for me, because as I go through the process of figuring it out, the reductions are always going to work in my favor. So then I just say, all right, I've got an opposite and an adjacent, and I'm going to have to do an inverse cosine. If I need my inverse cosine, what I'm going to need is my adjacent over my hypotenuse. I have my adjacent. What I don't have is my hypotenuse. So I'll go through the process of saying negative 2 squared plus 1 squared is equal to h squared. 4 plus 1 is equal to h squared. 5 is equal to h squared. So then my hypotenuse is equal to the square root of 5. And it's going to be the positive square root of 5 because hypotenuses cannot be negative. Our hypotenusi are always positive values. So I have a positive 5 for my hypotenuse. And then I can say that the cosine of theta is equal to negative 2 over root 5, which means that theta is going to be equal to the cosine inverse of negative 2 over root 5. And when I plug this into my calculator, I'm going to find that this is equal to 2.68 radians. This one does fall in quadrant 2. This does work out in my favor. So the cotangent on the calculator gets a little bit complicated. Secant and cosecant are very straightforward. They're very easy. I just take the inverse of the reciprocal of sine or cosine, depending on if I'm talking about cosecant or secant. Cotangent, you can always use your cosine. You can always go through and solve for your hypotenuse. The book even tells you to do that. The book will have you use the inverse cosine for a positive or negative cotangent value just to get you in that habit. Me personally, I'm going to make my life a little bit easier. I don't want to solve for a hypotenuse if I don't have to. So if I'm looking at a cotangent in quadrant 1, I just go ahead and do the inverse tangent of the reciprocal value. If I have a cotangent in quadrant 2, unfortunately, I do have to go through and find the hypotenuse. There's just no way around that. And to work with what I have with the TI-83, I have to go through the process of finding that hypotenuse. All right, now using inverse trig to find some values here, it's really good that we did go through the process of finding the hypotenuse there, because now we're going to be able to find the exact value of any trig function knowing what we're looking at. And obviously we have the tangent inverse of 1/2 to start off with. Tangent inverse of 1/2, we don't have any unit circle angle with a tangent of 1/2. But what we do know is that I'm saying that I've got some tangent theta which is equal to 1/2. So that means that I'm looking at some angle that is in quadrant 1 because this is positive, where I've got this angle theta that is coming out, and I know that my opposite side is 1 and my adjacent side is 2 in quadrant 1 because I'm talking about the inverse tangent, which is opposite over adjacent. Now I take the inverse tangent of this angle, and now I'm saying that I need sine of whatever theta this is. I want to figure out what is the sine of this theta. Well, I don't need to know what this exact theta is. We've already done something with 1 and 2, so I can already tell you, you can look at the previous slide to figure out how I get here. My hypotenuse is the square root of 5. And now that I know this, now that I know what my tangent is, I know my opposite, I know my adjacent side, and I know my hypotenuse, and it's telling me figure out what the sine of whatever theta this is. Oh, well, I know that the sine of this is just going to end up being 1 over the square root of 5 because I'm talking about my opposite over my hypotenuse. I rationalize that out, and I say that my sine of theta here is going to end up being the square root of 5 over 5. And that's my answer. So I'm going through the process of saying, all right, I've got this triangle. I know that my opposite side is 1 and my adjacent side is 2 because I'm taking the inverse tangent of that. And then if I want to find the sine of that, all I need to do is find my hypotenuse value, and I can plug that in, and then I can just set up the ratio as is. And then I have my trigonometric ratio of sine, and that's my answer. So another example of this, we'll look at this again. I've got the cosine of the sine inverse of negative 1/3. And what I can say here is, all right, this is a quadrant 4 angle, first of all, because I'm talking about an inverse sine, which is negative. And since this is an inverse sine, which is negative, that means it has to fall in quadrant 4. So I'm going to go ahead and actually draw this triangle out. I always do these when I have these types of problems because it helps me visualize it. I know that my opposite side is going to be -1, and I know that my hypotenuse is going to be 3 because I'm being told that my sine of theta is equal to -1/3, which means that I've got my opposite over my hypotenuse. Obviously, in quadrant 4, my y value is already negative, and my hypotenusi are always positive values. So I've got that -1, and I've got that 3. And then I just have to go through the process of figuring out what is that adjacent side. So I'm going to say 3 squared is equal to -1 squared plus adjacent squared. I've got 9 is equal to 1 plus adjacent squared. 8 is equal to my adjacent squared. 2 times the square root of 2 is equal to my adjacent side. So now I have this adjacent side with a value of 2 times the square root of 2. And now I go through and I say, all right, that means the cosine of whatever theta this is going to be equal to its adjacent side over its hypotenuse. We just found the adjacent side and we already have the hypotenuse. So my cosine of this theta is equal to 2 root 2 over 3. And that's my final answer. I stop there. So it's the process of going through and understanding what sides you're being given, drawing out your triangle, making sure you know which quadrant you're in. It changes depending on if you're being asked inverse tangent, sine, cotangent, etc. You have to pay attention to which quadrants they fall in because that's going to tell you if your x or y values are positive. And then you can just go through and use the Pythagorean theorem to figure out what is the missing side, whether that be your opposite, adjacent, or your hypotenuse, and then plug that in to your trig ratios to get your answer. We'll do one more here. So I'm asking for the tangent of the inverse cosine of -1/3. This is the inverse cosine of a negative value. And since that's the inverse cosine of a negative value, I have an angle that falls in quadrant 2. So now, even though I still have this -1/3, it's no longer in quadrant 4, it's in quadrant 2. So I have this theta which arises and goes this way. My adjacent side is -1, my hypotenuse is 3. We've already solved for what that missing leg would be, so I have 2 times the square root of 2 for my opposite side. I want to know what my tangent is. We already know that tangent of theta is going to be equal to your opposite over your adjacent. So we know that our tangent of theta in this case is going to be 2 times the square root of 2 over -1, which we can just simplify to -2 times the square root of 2. We have to just go through the process of figuring out what our triangle is. And we can get exact answers this way. Yes, you could theoretically do this on a calculator. However, they're going to give you decimal approximations in a lot of cases. And again, if you are in AP Calculus and you're taking your exam and you're on the no calculator section, you won't know what to do. We have to go through the process of drawing these triangles. It works out for us. It's not super difficult. We just have to consider which sides we're being given and what we can do with those sides. The final thing here, this is a little bit more complicated and something that you would really kind of start approaching a little bit more at a calculus level. It says find the sine of the tangent inverse of u as an algebraic expression containing u. So what this means is that we're going to be able to find something here that isn't quite an answer per se. We're going to actually have an algebraic expression as our answer. We're not going to have a number as our answer. This is something that you would kind of have happen a lot more in calculus. Not this exact question, obviously, but this style of question where you're going to be writing things out as expressions to figure out, but we want to start getting used to that. I'm going to go ahead and I'm still going to say, all right, this is a positive angle, so I'm still talking in quadrant 1, which is going to make my life a lot easier. So I'm going to go ahead, I'll draw out my coordinate plane, and then I'll draw a triangle. And I've got some theta, which I'm trying to consider, because we know at the end of the day, we're still trying to figure out what is the sine of that theta. This is our end goal right now. Well, I'm going to think about this u, and I know that I can write this as an algebraic expression. It's not asking for an exact number, which makes my life a lot easier. What I'm going to say here is that my tangent of theta is equal to u. And I can rewrite that as my tangent of theta is equal to u over 1, because I can divide anything by 1 and still have it be itself. This means I can label u as my opposite side and 1 as my adjacent side. So u will be equal to my opposite side, and let's write that out. And 1 is going to be equal to my adjacent side. Then what I can do is I can say, all right, my hypotenuse here, or my hypotenuse squared, is going to be equal to u squared plus 1 squared, which I can just rewrite as my hypotenuse squared is equal to u squared plus 1. I can't add these together, but I can still make a representation of my hypotenuse. I know my hypotenuse is going to be a positive value, and I know that it's going to end up being the positive square root of u squared plus 1. I don't know what the value of u is. I have no clue what the value of u is. But I can go through and still create this theoretical idea. This allows me that once I figure out that number, any number of my tangent can be now plugged into this formula. This is almost giving me a formula for if you're given the inverse tangent first and I want to figure out what the sine is. But what I can now say is that I've got this side of my adjacent 1, this opposite of u, and this as u squared plus 1. I can still say that my sine of theta is going to be equal to my opposite over my hypotenuse. So I'm going to say my sine of theta is going to be equal to u over the square root of u squared plus 1. So this almost gives me a general formula at this point, that once I get a number for tangent, all I have to do is start plugging it in. So if I had the sine of the tangent inverse of any number, I can just plug it into this formula and it would end up being the exact same. But we're looking for that algebraic expression. And since these are video notes and I have the time, on the homework slide, I'm just going to go ahead and show you that for fun. Why not? So if I was being asked for the sine of the tangent inverse of, let's say, 3, I could go through the process of setting up my opposite side of 3, my adjacent side of 1, finding out that my hypotenuse is the square root of 10, and then saying that my sine would end up being 3 over the square root of 10, which would work out. Or I could put this into my sine of this would be equal to u over the square root of u squared plus 1, and I could say that my sine is now equal to 3 over the square root of 3 squared plus 1, which we can quickly see is that my sine is 3 over the square root of 10, and that works out well for me. So all I've done there is just kind of something for fun because it just popped in my head and I figured why not. And I saw that what we ended up doing in this was creating this formula. And this allows us that now if I had that sine tangent inverse, I can just plug in that formula without having to go through the process of finding my hypotenuse every time. However, I still want to write it as an algebraic expression. And I want to get used to this idea that I don't have to have an exact number as an answer. That sometimes finding formulas and working them around is a better idea and more so what I need. For all of the students who are in physics, honors physics, you guys did a lot of this at the beginning of the year. You worked a lot with deriving your formulas and rearranging them. And that's kind of the same idea here, if we want to move things around and make them fit our needs. You guys have a homework assignment. I'll make sure to do a few examples on your homework so that way you get used to it. Please reach out to me with any questions and have a great night.